students, in arrays operation lecture 2 part 2nd. In the previous lecture I taught you about some basic operations in arrays or some matrices, which was just like that. And in this lecture we will cover arrays building functions. I just gone through an arrays function which is EYE, that is basically it meaning the identity matrix. Let you remind identity matrix how to use the identity matrix. Just give command in command window EYE identity matrix of let's say 3 by 3 and just enter. You'll get an identity matrix and it will be saved in the variable ANS. So it was identity matrix. Moving on, the first was ones. Ones is basically building M cross and matrix of ones. So let's just see how ones is working. Now put ones and let's say 3 rows and 2 columns. So it will basically give us matrices of which containing same value which is 1 in 3 rows and 2 columns. As you can see, it gives us a matrices of 3 rows and 2 columns. Let's just save it on an variable j. J is equals to ones let's say 3 comma 3. So it will give us a 3 rows and 3 column matrices which contains ones, and it has a it is saving in a new variable called j. Likewise, if I want to know the size of j, we simply put a command size size of size j. So it will give me a size of j which is 1, 1. In the previous lecture, let me remind you something. Let's go to zeros, m and n. It will also gives me zeros of let's say 2 comma 3. So it is a zeros functions of building arrays functions, which is basically we will build multiple arrays like we have just gone through E by E. This is identity matrix, diag vag create a diagonal matrix, diag a diagonal elements of matrix A, rand. Now coming to the let me go through a diag function. Okay, so let's just call um, a way of matrix F. It is matrix F and it is not a square matrix. Diag matrix is only working on a square matrix which contains, let's create identity matrix. Identity matrix is a square matrix. Take an example of I, which is an identity matrix. So when we give a command in command window, diag of I. So as you can see, diag of I is gives us 1 1 1, which is a diagonal elements of matrix I. Okay, now coming to the next array building function, which is rand. Rand is basically denoted by a random number. Okay, so when I put a simple rand command, it will give me a variable or a random number which contains 0 point something like that. Okay, now coming to the rand, if I give me rand of let's say 2 comma 3, so what will it give me? This command will give me as 2 rows and 3 columns random numbers matrix. Okay, let's say, so as you can see, it contains 2 rows and 3 columns with random numbers of matrices. Now, what is the main difference? Okay, now coming to the next point, rand n, it will give me a Gaussian random number array. Rand n. Let's do the example of rand n. Rand n will, let's say, 3 comma 3. It will give me a Gaussian numbers of 3 rows and 3 columns matrices. As you can see, it gave us a 3 rows and 3 column Gaussian numbers matrices. Magic M and magic square matrix. It is nothing but a magic square matrix. Magic sorry, magic. Let's say 3. Okay, it would give me a 3 by 3 which contains 3 rows and 3 columns magic matrix. Magic matrix is what? Which contains 1 to 9 whole numbers. As you can see, 1, 2, 3, 4, 5, 6, 7, 8, and 9. It will give magic numbers of G containing Z. Okay, let's put another magic matrix. Magic, let's say 2. It is a 1, 2, 3, and 4. Okay, now let's contain a new magic matrix. Magic which contains 2 rows and 3 columns. Let's say what will give us. It says it gives error. Too many input arguments, which means it has too many output arguments. Okay, let's say another magic matrix, 3 rows and 2 columns. Let's say if it work or not. It also gives us the same error. So what the conclusion? The conclusion is magic matrix is only working, or magic matrix is only command which only made for the square matrix. Okay. Likewise, we have 4 rows and let's say 4 columns. So if it gives us a 4 rows and 4, now 4 rows and 4 columns will just let down the input variable, which is 1 to 9. 1 to 9 cannot got inputted in the 4 rows and 4 columns. Let's say magic, let's say another magic 3 rows and 3 columns. What would you say? It would work or not? Let's say it is also not working. Let's say more magic. Let's put a magic number 4. Okay, so it gives us a magic number 4. Okay, we have Hilbert matrix also. Let's say Hilbert of Hilberts of 3. It will give me Hilbert matrix. Hilbert matrix is what? The first is continuously decreasing matrix. The first element is 1, second is 0.5, third is 0.33. The second row will start from the second column, which is 0.58. Let's assign it a new value. Let's say x is equals to Hilbert matrix of 3. Okay, so we assign the value. Now we have to find out x prime, which basically means the x transpose. As you can see, the x transpose or the x prime is same. Moving on to the next slide, which is matrix operations. We can do several matrix operations on 2 or 3 matrices or 2 or 3 rows. So coming on to the matrix operations, we can do a scalar operations like plus. We can add 2 matrices. We can divide 2 matrices. We can multiply 2 excision. We will working on this. Okay, we will working on division on the next chapter because it is an advanced feature of matrices, so we will learn it in next unit. Let's take an example. let's recall an identity matrix. It is a square matrix of size 3 rows and 3 columns. Let's multiply I times I. It also give me a identity matrix. Okay, so if you have any problem, let's create a matrix G. Let's recall the matrix G. Oh, so it's a row matrix. We will just let's create a matrix like y. Y would be a matrix of 1 comma 2 comma 3 and 4 comma 5 comma 6 7 comma 8 comma 9. So y is a square matrix of size 3 and okay. So as we know, the first operation of matrix is plus. So let's do some plus matrix. Let's call y plus I. So this would be the uh, answer of identity matrix I and square matrix y, and it is assigned a new variable called ans. Similar like that, we can do minus operation of it. Let's took an example y minus I. So here is the answer of y minus I. We can also multiply this y multiplied by I. It is like that, and y divided by I. We have to be so careful about divide by y. Let's y divided by I. Let's see what happened. It just give us a similar value because I is an identity matrix. So there is a function which is a power function. This is a power function. So what does it mean? So let's say y its power, let's say 2. Okay, so y that's power 2 is y square, basically multiplication of similar matrix like y multiplied by y. It would be the same answer as y square. As you can see, it is the same answer of y square. So it is some basic mathematical operations which we can apply on matrices or array. Log m or exponential m, it is the new operations which only concluded on a matrix. Let's recall a matrix called um, let's recall a matrix which has let's x call an x matrix. It is a Hilbert matrix basically, but it is a square matrix. Okay, so let's 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 do the first is let's compute the first operation which is log m. So first we have to do log of x. Okay, log of x. So what would happen? What is different between log mx and log x? So log x will it will give us a matrix which has which will every element will got its log. So as you can see, every element will got its log, and it gives another matrices, and it was assigned a new variable called ans, which is a default variable. Okay, so next what's difference will be log x and log m x. First, it would only create it would give me an answer of matrix x logs. Okay, so as you can see, the variables are at here are different. Okay, similarly we can go through exponential m, power m, and square reduction m, sum, prod, cum sum, and cum prod are the length, minimum. We go through size of eig, mean, sum, and we will working on some operations. Let's do some operations. So coming to the sum prod and come sum and come prod. So what is let me clear the command window first. Okay, so sum means the sum of each element. Let's call um, a row vector a. So when I applied a sum function, sum of a, basically what would happen, it will just got added of each element and give us another vector. So 1 is got is individual, then 1 plus 5 will get 6, and 1 plus 5, 1 plus 6 plus 9 would give us 15. So let's, it will give us a sum of all elements, which 1 plus 5 plus 9 is basically going to be 15. Okay, so let's look come sum. Come sum will give us of come sum of a will give us basically a new row vector of um, commutative sum. Like first element will going to be 1, second element will going to be 1 plus 5, which is going to be 6, and the third element will going to be 1 plus 6 plus 9, which is going to be 15. So as you can see, first element is 1, second element is 1 plus 5, which is 6, and third element is 1 plus 6 plus 9, which is going to be 15. Okay. As you can see, the command prod is basically nothing but the meaning, it is a multiplication of each element. Okay. So let's call prod a. Prod A is basically give us multiplication of all elements, like 1 times 5 is equals to 5, and 5 times 9 is equal to 45. It will give us a result of 45. So come sum is nothing but it also, sorry, sum prod is commutative multiplication of each element in a row matrix or in a matrix. Okay. So come sum of A would give us another row matrix of commutative multiplication. Like first multiplication would be 1 times 1, second multiplication would be going to be 1 times 5, 5, and the third computation is going to be 1 times 5 times 9, which is 45. So answer would be 1, 5, and 45. Let's say come prod of A. So as you can see, the come prod of A is equal to 1, 5, and 45. Let's clear this thing. So we're just going through um, um, come sum prod, come sum, and come prod. These are the another matrix operations: minimum, maximum, mean, and standard. We will go into in the next chapter, or you can just try it at home. So length and size we just gone through previous lectures. Like if a matrix has 5 times 1, and we just gave its command length of that matrix, so it would be the 5. Okay, so let's create a new matrix. Let's say it has the q is equal to 1, 1, 2, and 5, 6. So it is a new matrix, basically square matrix. Okay, so there is a there is a there is a new operation which can do element by element subtraction, element by element multiplication, and element by element addition. So what we have to do by element to element operation? Okay, so we have q, we will put a dot basically in something like that. Okay, dot plus q. So it would give us element by element addition. So what would going to happen at here? So first q plus, so q has a 1, 2, and 5, 6. So what is going to this matrix is also a square matrix which has elements 1 plus 1 plus 2, 2 plus 2 is 4, 5 plus 5 is 10 and 6 plus 6 is 12. Okay, happened at here. So it says, and it gives an error basically. It says invalid use of operator. Okay, so it gives us an invalid use of operator. So q plus q. mm, so this is going to be um, um, this is going to be answer of this matrix. Okay, so um, at the so at the near at the I'm going to be end this lecture, and in the next lecture we will learn um, some good examples of these array operations and matrix operations. So till then, first you have I will actually remind you how to clear this workspace variables. In the previous chapter I also told you, but let's say clear all. When you put that command in command window, the variables at workspace will go clear. Okay, so by this end chapter we will moving on to the next chapter, and happy learning and goodbye. This is me, Mukesh Prajapat. So I'm going to end this chapter at here. We will learn a new things in the next chapter. Thank you. Bye bye.